In this video, we're talking about constructors. And this is in the same packet of notes as the previous lectures. Last time we were building a new data type, a student type that encapsulates information about a single student. It stores information about their last name, first name, GPA, and credits, all bundled together into a brand new data type that we're creating from scratch. Last time we also wrote a main method, part of the main program, that allowed us to declare objects of type student type. And then we also used the setter methods within the student type class to store information, to take information from our main program and put it into these bundled objects. We created two of them, student 1 and student 2. So last time we learned about how to assign values to a particular object, how to take data from our main program and put it into an object of this new data type. And that was fantastic. We could do that effectively, but it had some drawbacks. Assigning a value to a variable is a really common operation. And we'd like all of our variables to have a stable initial value as soon as they're declared, not be dependent on somebody who's using our class knowing that they're supposed to call particular setter methods before the data that's inside that class is reliable. And so Java provides us a way of doing that, a special method that's called automatically when an object gets instantiated. So as soon as you're declaring an object of type student type, this particular method would get called. And that special method's called a constructor for the class. And the whole purpose of a constructor is just to initialize the data fields within the object. Sometimes people try to write constructors and they add some extra stuff in there like print statements, trying to read data from standard input. None of that's supposed to go inside a constructor. The whole purpose of a constructor is just to initialize data fields. And the constructor in that way creates an initial reliable state for the object. Now, because these constructors are called automatically, Java has some special rules that you have to obey when you're writing a constructor. And here's the rules. Constructors have to be named the exact same thing as the name of the class. So if your class is called student, your constructor has to be called student. If your class is called student type, your constructor has to be called student type. The second rule is that constructors cannot have a return value, not even void. So you can't put any return value over there on the left-hand side of the method header in the way that you're used to doing. And then the final rule isn't really a rule, it's just something I wanted to mention, and that's that a single class can have multiple constructors as long as the signature in each is unique. Take a minute and see if you can remember what the signature for a method means. Talked about that a few weeks ago. So the signature for the method is the parameter list. It has to be unique in the number or type of parameters that are required. So it has to be able to immediately distinguish between different calls to a method if they all have the same name. And since constructors all have to be named the same thing as the name of the class, we have to have a unique signature for each. Otherwise, the compiler can't tell them apart based on context in our code. So today we're going to write some constructors for our student class. I feel like I had some, no, maybe I didn't. All right, so we're going to write some constructors for our student class. First, we're going to write a constructor that doesn't have any parameters associated with it. And that's a special kind of constructor. We call that the default constructor. It's the constructor that gets called if you don't know anything special about how to set up the class. It's just going to initialize everything to a reliable state. So you probably remember our student data type has the last name, first name, GPA, credits earned inside of it. And it really doesn't make sense to initialize all of those pieces of data. For example, if we were trying to initialize a brand new student object, we wouldn't want to like store the name like Jane and the last name like Jones in there by default, because most people's name isn't Jane Jones. And so that's going to apply to like 1 in a million objects that we're trying to create. But it does make sense to initialize some of the other data. If we have a brand new student, we don't know anything about them. As soon as you enroll in UMW or another university, your GPA starts at 0.0 because you haven't taken any courses yet. Similarly, your credits earned at that university starts at 0, assuming you don't have transfer credits or anything like that. So if we're trying to make a brand new fresh student object, we could initialize the value of these two data fields within the object so that they store the value 0. And that's what we're going to do in our constructor. So the constructor that's part of the student class, it would go inside your student.java file, or mine's called studenttype.java. And it's a method, so it would go underneath the data field declarations. I'm going to put it right here. And remember that it has to start with public, that's so that we can call it from outside the class. And then the name of the method has to match the name of the class. So mine's called student type here. I'm going to type student type. If you were following the examples from the notes, you would just call it student. And then this one doesn't take any parameters. It's the default constructor. So an empty parameter list is just open close parentheses. And then I'm going to create the curly brackets to start the method implementation. And again, all I want to do in here is initialize my data fields. My data field in my data type is called GPA, all lowercase. So I'm going to set that to 0.0. And then my credits is called credits. I'm going to set that equal to 0, integer value. And again, I could initialize the first name and last name to something, but any name that I picked for those is just going to not make sense for most people. So I'm just going to leave those blank. And we should comment our method. You know about that, we should put in a java.com comment. So I'm going to start it with /*, and then hit enter, and it'll fill in a lot for me. Oh, it didn't fill in anything this time, but I can fill it in, that's fine. So this is my default constructor that initializes the GPA and credits for a new student. And it doesn't have any parameters or return types, so I don't need any other tags in that particular method. Cool. So again, notice we don't have to initialize every data field inside our constructor, just the ones that make sense. It wouldn't make sense to assign default values for a particular student's name. Does make sense to initialize a GPA and credits. So that's one kind of constructor that we can make for the student type. We're going to make a second constructor for the student type because while it's possible that we're making a brand new student one who doesn't have any real data associated with it, we also might be trying to initialize a student kind of like in the situation that we had in our main program last time, where we had read in a bunch of data from standard input, and now all in one step we want to initialize the student type or the student variable so that it has all of that data that we've collected in there. So we're going to make this second constructor. This one's going to require parameters, and that makes it a non-default constructor. Maybe I should have written my method first, because I think this one will fill in some stuff for me. So again, it has to be of type public because you can call it from outside the class, and there can't be any return type. And then we have to call it the name of the class, so student type's my class name. And this time I want it to be able to read in information that allows me to initialize all my data fields. So I want to be able to put in a string that means the first name, a string that means the last name, a double that means the GPA, and a double that means credits. Cool. And then I want to use all of those data values to initialize my data fields that are part of the class. So my data field names are first name. I'll set that equal to something. Oh, it's going to like mess up my indentation if I don't like fill it in right away. All right, so I want to initialize first name. I'm going to use my first parameter to do that, FN. And then I want to initialize last name, my data field that represents the student's last name. And I'm going to initialize that with LN, my second parameter. And then GPA, I'm going to initialize that with my third parameter, capital GPA. And then my last data field, credits, I'm going to initialize that with my last parameter, credits earned. So the operations we performed there, oh, my credits were supposed to be integers. Oops. The operations that we performed there is kind of like all of the operations we had in those setter methods. It's just joining them all together in one spot. So rather than doing them one at a time separately, we're doing them like all in one step. And the advantage of doing them this way in the constructor is that we know that when we declare an object of type student type, one of these constructors can get called, and then we'll know that the object is at a reliable state as soon as we create it. So at this point, the notes are just reviewing like what would be inside your student type or student class, and it'll closely match what I have in my student type class. The names and capitalization's a little bit different, but the big picture ideas are exactly the same.